This summer we met as a department and we did a training on high cognitive demand tasks, and I've seen teachers really implementing that in their classroom, giving tasks to students that require them to think. I did notice, however, that a lot of the time students were presenting their solutions because they wanted to. It was self-selection. I really wanted teachers to intentionally pick the solutions that they wanted the students to show, and I wanted it to be in a certain order to get the instructional goal across. My learning goal today for the teachers was to get them to anticipate students' responses before students even began the task, then to go around and monitor those responses as students were working, and the most important goal of today is I wanted them to sequence those responses in an order that makes sense for that task.
Right. Oh, you're using 1.8 as 9/5? Okay. Yeah.
And then this one, I was like, well, what temperature is it?
34
Give
degrees.
an answer that's too high. What temperature are we talking about?
I think they're talking about Fahrenheit temperatures. So what Celsius temperature gives us Fahrenheits that are too high for permanent? So in order to find out where that breaking point was, I set the two equal to each other.
Hers, it was too high at 18 also.
Yeah.
Because the actual should have been 64.
Right.
And hers was 66, so you have to go lower.
Try 17.9.
Still the same at 3.
Why don't you do 17.5, I'll do 17.5.
Can you make like a table or a chart that shows?
Right here. Well,
Okay, yeah, just put it like
I mean,
like a visual.
1 would be 32.
Mm-hmm.
2 would be 34.
Right.
3 would be 36.
And then they can see a pattern as it's going up, you know?
And 4 would be 38.
just
So it's add 2 for every one that you add.
I like that. And we can make an algebraic expression.
X and Y.
Right? It increases. Ooh, good job, Kelly.
And then I looked at her and I said, there has to be an easier way to do this. So then we didn't get we saw that as we went down further and further, so then we started going down more. And then you got to
Technically 50 degrees Fahrenheit and 50 degrees Fahrenheit. So we figured that anything over 10 degrees, but we did the guess and check, so.
right, which was not the most efficient way.
Yeah, because look at, I mean, hers and mine, and then we were doing all different numbers, so.
Okay. So we just made the chart and then we kept doing it and we came down. And then Frank came up with 15 plus 15 was 30. And then the 30 plus, what was on the paper? 30 plus?
30 plus 38.
38 gave us a 68. So we came to the conclusion of 15, but we didn't do the chart all the way down to see if it ended up where they said at 10 and 10.
Okay, so you're...
All right, so first what our group did was we all double checked to see what the first set of answers was, and I just put what they'd given in Word format into more of an expression form because that's what I'm comfortable with. And I used X instead of C for Celsius, but you guys get that it's just a variable there. So John's answer gave us 68, Ann's answer gave us 70. And then I was thinking back and I was like, okay, well there's got to be some point where these two actually work out even. So I thought, what if I set these two expressions equal to one another?
Yeah.
And as you work that out, you get x equals to 10. So at 10 degrees Celsius, they have to be, I mean, that's kind of the breaking point. And just from looking at part 1, I thought, okay, above 10 is most likely going to be Ann's numbers or higher, but I wanted to double check, so I made a chart down here with 9s to see if it would in fact be lower at that point. So in fact, John at 9 gets us 48.2, Ann gets us 48. She's lower at anything less than 10.
So I want to show you now what I was doing as you were working. This is a little bit of modeling. So let me show you this really neat organizer that I stole from somebody sitting in the room. Okay. There's a book called the 5 practices for orchestrating a mathematical discussion. And in this book, they talk about the 5 practices that you need to use. So since that's kind of hard to see, let me pass this out to you so you can follow along. The first one is anticipating. It says anticipating likely student responses to challenging mathematical tasks. So the first thing I have to do while getting ready is I have to think, what kinds of methods are my students going to use to solve? I have to anticipate that. So I wrote the methods that I thought I was going to see. And I saw all 4, which was cool. I don't think that's going to happen to me likely, often. But so I saw writing expressions, I saw making a table, I saw guess and check, reasoning that 9/5 was 1.8. And then there's a place for other strategies that you're not expecting as you're walking around. Then the next thing that you want to do while students are working is you want to monitor. Monitoring students' responses to the tasks while students work on the tasks in pairs or small groups. So I was walking around and I was saying who and what. So who was writing expressions? I saw Michael right away. And then I saw Angel doing it too. She just didn't set them equal to each other. Making a table, 6th grade ended up doing that. Guess and check, there was quite a few people that started on that track. And then Lisa and Ashley continued it all the way through. So I
persevered.
And then I saw that Lisa had written 1.8 instead of 9/5. So that was the second thing I needed to do. After I knew in my head, like I had these little numbers here before I even started, I knew that I would want the person who did guess and check to go first. Because that's one that everybody can understand right away. It makes sense, that's what we all probably went to, most of us. Then I said, well, guess and check gets kind of messy, so let's take a student that organized their data from that method. Then it would make sense to present whoever wrote an expression and set it equal to each other. That was kind of the most efficient way. I struggled with how to tie this in, but it was nice because Lisa did that for me. So I knew the order I wanted to present in, so all I had to do was pick the students that I saw that really understood it and could present it to the class, or that maybe had questions about it and could bring up those questions in front of the class. So I picked the order that I wanted it to go in. That was the sequencing. And then connecting students' responses to the responses of key mathematical ideas. That's something like at the end, if you were to do this next time, how would you do it? Or where does this 9/5 come from? How does it make sense? Well, today we started the process of practicing this skill. I first modeled the anticipating strategies, sequencing, and selecting, and then I wanted them to practice it within their PLC. So they brought their own high cognitive demand task that they will be working on upcoming curriculum, and they practiced anticipating those students' responses. So I was able to do some formative assessment by walking around the room during that time of their discussion and seeing where the teachers were at with this process. I want to continue to make sure that they understand how to sequence and monitor by going into the PLCs and going into classrooms and continuing with that coaching cycle by looking for implementation.
May I just say that I think that the selecting is one of the most important parts of this chart, because I know as teachers we walk around, we monitor, we see something, we put it under the Elmo machine, but I have a bad tendency to grab the one with the algebraic expression first. So to me that was like a light bulb moment, and I would now make sure that I use the table or the chart first and then gradually increase their knowledge until we got to that higher cognitive thinking. So I really enjoyed that.
Thank you for my